Hey you guys, this is Mr. Sal. It's a quick lesson on multiplying radical expressions. Thanks for watching. Don't forget to like, comment, and subscribe. Again, when multiplying radical expressions, I guess we're kind of I think we're going to be looking at the product rule, I would assume, on that. Or even perhaps maybe the power rule or this expanded power stuff, right? Because all exponents are just repeated multiplication. So we could write it, I don't know, something like that. If we see fractions, something like this. Maybe not so much of the negative exponents. I really highly doubt we'll see any zero exponents because it's too easy. Whatever. So multiplying radicals, yeah, if we look at something like this, see how the roots are the same value? In this case, it's n. I mean, we would expect a number there, maybe 5 or something like that. We can rewrite it as one full radical and just multiply the a and b values, the bases, just like we would as if it were something like this here at the bottom. I mean, if you want to look at it as the exponents being the same, then we could change that to a times b to all of that to the power of 1n. This works backwards, by the way, because it may be convenient eventually to break up, I don't know, an expression that looks like that. I guess this is a little different. Simplifying these, some of your calculators would do this for you, and that's great. However, well, I think mine does, but I don't know if yours does. So here we go. So this is the square root of 24, 5 times the square root of 24. So I'm going to do the prime factorization of 24 just so I can see all of its factors, okay? I see 24, it's even, so it's divisible by 2, which is prime. And it would be 2 times 12, and 12 is 3 times 4, or 6 times 2, whatever. And then 4 is 2 times 2. So what I end up with is 5 times the square root, and I'm going to move all the numbers that are the same next to each other. 2 times 2 times 2 times 3. Now the reason this is important is because this is a square root, and remember, we don't usually write the index for square roots. However, the 2, just like as if it were a 3 or 4, tells us how many we need to make a set of something. In other words, I need 2 2's in this case in order to pull it out. What that also means is that 2 times 2 is a perfect square. So the square root of 2 times 2 is 2. And I've got 5 times that 2. Yep, so now we'll just multiply everything to simplify. 5 times 2 is 10. And I've got the square root of 2 times 3 is 6. Done. 3 times the 7th root of 384 times x to the power of 14 times y to the power of 31. We'll get to the exponents here. I'm going to split this up actually. So I've got 3 times the 7th root of 384 times the 7th root of x to the power of 14 times the 7th root of y to the power of 31. Now there's a reason I've done that. One of the reasons is to split this up into smaller, hopefully simpler problems. And so I'm going to take that 384 and start splitting it up into its prime factors. 192. All right. So that ends up being the 7th root of 1, 2, 3, 4, 5, 6, 7 2's and a 3. And yeah, we'll end up multiplying this by the 3 in the front there. Well, since this is the 7th root, I need a group of 7. I didn't write enough 2's, did I? No. I need another 2. I need, sorry, 7 2's in this case in order to pull 1 2 out of this thing. So I've got 3 times 2 times the 7th root, because we still have that 3 that was left over. I had no other groups of 7 to combine with. And I've got the 7th root of 3. Well, 3 times 2 is 6. So 6 times the 7th root of 3. Well, that was just the numbers on that. And yeah, some of you guys did the 7th root of 384, and your calculator gave you 2 times the 7th root of 3, but whatever. The x's on this one, I want to change it into a fraction, the exponent. So this is going to be x to the power of 14 sevenths. And yeah, I did that right, because I know 14 is divisible by 7 evenly. So it's really x to the power of 2. And if I would write, I'm just going to bring it down with the rest of this expression, x to the power of 2. Y to the 31th, though, is not as convenient, and that's okay. Because here's what we'll do, is I'm still going to write it as a fraction as 31 sevenths. But what I really want there is the mixed number, okay? So this ends up being y to the power of 4 and 3 sevenths. All right, well, this is really 4 plus 3 sevenths. And if I were to change that into 2 different y's, I'd have y to the power of 4 times y to the power of 3 sevenths. The only reason I show this is to show how many y's are going to come out of that 7th root. And, well, we get 4 of them, right? Y to the power of 4. And I'm going to rewrite this y to the power of 3 sevenths as a root, 7th root of y cubed. Okay, let me just rearrange these so that all the non-7th roots are out of the way, I guess. But remember, if we have the same roots, then we can combine those two. So in other words, I'm going to take this 7th root of y cubed, and I'm just going to make it one radical there. So I've got 6x squared, y to the 4th, and just to separate those, multiplied by the 7th root of 3y cubed. Done. This is a cube root, and we've discussed this before, but it's maybe helpful, should be helpful to memorize. I don't know, I'd say the first 5 cubes. So for example, 1 cubed. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. And just for the heck of it, 5 cubed is 125. Now the only reason I show this is because the more familiar we get with these and the better we can memorize them, the more likely we are to see that 64 is a perfect cube, okay? I don't know. I guess what I want to do with that is change these all to fractions. But to do that first, I'm going to split it up. Okay, so just splitting this up, this is all multiplied together. And then, well, I guess we don't really need to change 64 to the power of 1/3. Because we know 64 is a perfect cube. So the cube root of 64 is 4. The rest of these, though, I will be changing into fractions. So this is really f to the power of 9/3. A to the power of 18/3. And yeah, you guys are seeing the convenience in all this, hopefully. B to the power of 24/3, right? All of those exponents are divisible by 3. So what I end up with is 4 f to the 3rd power, a to the 6th power, and b to the 8th power. Done. All right, simplify this stuff. Before I simplify it, I'm going to rearrange it because it's all multiplication. So we can use the commutative property. So now I've got 2 times 4 times the square root of 35 times the square root of 14. And we could combine that 35 times 14, right, in its own square root. We're just going to be tempted to multiply those out, but in reality we'll probably need the prime factors for those. I mean, if your calculator doesn't do it right. We can do 2 times 4, and that's great. That's 8. But I got the square root. 35 is going to split up into 7 and 5, which are both prime. And 14 is going to split up into 7 and 2. And these are all multiplied. So I didn't multiply those because I'm going to need the prime factors anyways. Again, unless your calculator does it. Now we could rearrange this. And again, the only reason I'm rearranging it is so that we can see that I've got this pair of 7s, which is going to come out of that square root. Now I'll multiply 8 times 7, which is 56. And 5 times 2 is 10. 56 times the square root of 10, and that is simplified. Fifth roots. So we really don't expect you guys to memorize any fifth root stuff. Okay. Cube roots are good though. Since both of these are both fifth roots, we can just combine them into one. And I'm just going to rearrange these so that I can multiply stuff together. And I'll just start combining these. So 125 times 25 is 625. X to the fourth times x would give us x to the fifth. And y cubed times y squared is also y to the fifth. There we go. That's better. 125 times 25. Again, we can look at this all separately, right? So I've split this up. Some of you know right away, just the way that it was, that you could have taken x and y out. And that's okay. All right. If you plug the fifth root of 3125, because it is a perfect fifth, I guess, I don't know what to call it, 5. And then the x is x to the fifth, well, it's the fifth root of x to the fifth. So it's really x to the power 5 over 5, which is just x to the 1th. And same with the y's. Done. I did skip a step on that one. We can look back at that as well. 125 is 5 cubed, which we've seen, and 25 is 5 squared. So we can see that the 3125 is also 5 to the 5th power.